Let's dig deeper into the relationship between antioxidants and NAD+, because it's more specific than just general cellular protection. When DNA gets damaged, and it's getting damaged constantly in your cells from normal metabolism, radiation, toxins, and just the wear and tear of living, your cells activate repair enzymes to fix it. The most important family of these repair enzymes is called PARPs, poly-ADP-ribose polymerases, and they are absolutely voracious consumers of NAD+. Here's how dramatic this can be. When PRP1 is activated by DNA damage, it can deplete cellular NAD+ by 50% or more within minutes. Think about that. Half of your cell's NAD+ gone in minutes because of DNA damage. Now, if this happens occasionally, it's fine. Your cells can regenerate NAD+, and everything returns to normal. But if DNA damage is happening constantly because of chronic oxidative stress, PRP enzymes stay activated and continuously drain NAD+ reserves. It's like trying to fill a bathtub while the drain is wide open. This is where antioxidants become relevant in a very direct way. By neutralizing free radicals before they damage DNA, antioxidants reduce the frequency of PRP activation. Less DNA damage means less NAD+ diverted to emergency repairs, which means more NAD+ available for normal energy production, sirtuin activity, and other essential functions. It's not that antioxidants directly increase NAD+ levels. They preserve NAD+ by reducing the damage that forces cells to spend it. The foods richest in antioxidants are generally brightly colored fruits and vegetables. Berries, particularly blueberries, blackberries, and strawberries, consistently rank at the top. Dark leafy greens like kale and spinach. Nuts, especially walnuts and pecans. Dark chocolate with high cocoa content. Coffee and tea. Red wine in moderation. These foods contain various antioxidant compounds, from vitamin C and E to hundreds of polyphenolic compounds that can scavenge free radicals. But here's where reality checks are necessary. The relationship between eating antioxidant foods and measurably reducing oxidative damage in the brain is not as straightforward as we might hope. Many antioxidant compounds don't cross the blood-brain barrier efficiently. Those that do may not reach high enough concentrations to make a significant difference in the face of severe oxidative stress. And the brain's own antioxidant systems, including enzymes like superoxide dismutase and catalase, are probably more important than dietary antioxidants for managing oxidative stress within neurons. There's also the concerning track record of antioxidant supplement trials. Large studies giving people high-dose vitamin E or beta-carotene or selenium have generally not shown cognitive benefits and in some cases have shown harm. This paradox, where antioxidant-rich foods are protective but antioxidant supplements aren't, suggests that the benefits of these foods go beyond simple free radical scavenging. It might be about the combination of compounds in whole foods, their effects on gene expression, their influence on gut bacteria, or mechanisms we don't yet understand. Another complication is that some level of oxidative stress is actually necessary for normal cellular signaling. Free radicals aren't purely villains. They're used as signaling molecules for important adaptive responses. When you exercise, for example, you generate oxidative stress, and that stress triggers beneficial adaptations like mitochondrial biogenesis. If you completely suppress oxidative stress with massive antioxidant doses, you might actually interfere with these adaptive processes. This is called the antioxidant paradox, and it's one reason why more isn't always better. In Alzheimer's disease specifically, oxidative damage is severe and widespread. The hope that eating more antioxidant foods could significantly reduce this damage once it's established is probably optimistic. Where antioxidants likely matter most is in prevention, helping to keep oxidative damage at manageable levels over decades so that PRP enzymes aren't constantly draining NAD+. This is about maintaining balance, not about fighting a war against free radicals that's already been lost. The practical recommendation remains eating a diet rich in colorful plant foods that provide diverse antioxidants. But expectations should be realistic. These foods support NAD+ preservation through damage prevention, but they're not going to dramatically reverse oxidative damage or restore depleted NAD+ in someone with advanced neurodegeneration. They're part of a long-term strategy for metabolic health, not a therapeutic intervention for established disease.